idea being that it's a booster thing. When you go occupied, that the AV box will turn it on and it runs all day. It only turns off when you don't want it. You can get a parallel fan, which we can talk about. Parallel fan is only a cycle. It only comes on a call. The idea is to try to pull it back in, which is more like air. Hopefully they can do that up. But we don't have any parallel fan. We're 106 guys, but it's not covered. But we 105.
There's really no network available.
Yeah. All right, guys. Thanks for being patient. And behave. Or don't behave. But we don't post any mail. So you're on your own. Yeah, I got it.
That was kind of fun.
That was fun. How was that?
Yeah, I call safe. I call I can get my dad from a month ago. I assume I'm on Cortex. Yeah. Be careful. Yeah. That's actually at least I know, at least it's something like that. Like, oh, Lord, it works for,
That's through this, right? Yeah. Now, once it establishes a connection, I think I should be able to navigate through it. We don't have network. It happens. I'll text you stuff.
I would say it really not be, I'm very hard to do. Throw you into the wall. And I want to stay. It'll be deep on it.
is summer back home right now, right? Yeah, I had a brother that lived in Buffalo. He's now living in the Philippines. So I used to hear stories about, you know, where he'd try to get in his vehicle and it's covered in snow, right? You know, he'd be working 12-hour shifts, come out to the from his office. What the heck? How did I get my car out of here now? Right? It's not uncommon. How about you, sir?
I'm Alex Hunt. I'm up in Seattle District. And
Oh, wow.
Electrical customers.
Oh, cool, cool. I spent a lot of time up in Washington. I've been spending a lot of time at the DOE up in Richland, Tri-City. So applying to Seattle, Tri-City.
The eastern side of the state, you know, it's warm and it kind of like has this climate.
Yeah,
somewhat
but man, I
similar.
tell you, you know, it's funny because when you go to different parts of Washington, it's a lot different lifestyle. Yeah, it is. It really is. But it's cool. I've enjoyed it. My name's Ron Ariaga, so I'll be your guys' instructor here for the next hour and 45 minutes. So, again, a little bit about me. I've worked for Johnson Controls York, you know, for almost a little over 20-something years now. I've also got a few years with Trane, a short stint with Carrier as well. The only manufacturer is Daikin, but I've also worked for some other contractors. So I came up to Tools 10 years. This will be my 10th year as an instructor. So I teach a lot of the chiller courses. If you know some of our chillers, I mean, this is small potatoes right here. Okay? We make custom machines for all around the world. A lot of people don't really realize. There's anybody that ex-Navy here? Anybody ex-Navy? Okay, so ex-Navy.
No, NAFAC, I'm sorry, NAFAC.
Okay, NAFAC. Well, Navy, I had a student here that served in the Navy, works for the Navy Department as well. We build machines for the Navy, by the way. They're top secret, but you know, it takes a year to start to finish to let you know. So aircraft carriers, the big battleships, all the ships, the subs, nuclear subs, they have our machines on, okay? Which is, I'm not here to grandstand, but just letting you know that York is a custom builder for all different types of machines. We work off the offshore pipelines as well, oil rigs pumping crude out with our machines. So it's a lot, it's pretty cool. You know, you'll see some of our machines as well, converting one form of energy to another form at basically dump sites as well. So we're really involved in a lot of different type of processes. You know, the Olympics snowmaking machines, we've made those before as well. So we first came out with ice machines, so that's a little bit of history. So we'll get started here, but again, so YLAA chillers, okay? So this is an air-cooled chiller, by the way. So when you're looking at this machine here, you know, when this is being started up by a startup mechanic, this is all going to be done. When I say internally, that's from the Johnson Controls aspect, okay? They're not going to see an outside contractor. They might install it, but they should not be starting it up, okay? The other fact is, they probably don't have the education to start it up, okay? Because there's some things that need to be tested and all that stuff, and they may not know some of the passwords to get in there to do some of this stuff, okay? But when we get out there, I'm going to show you some stuff out there on the machine. We'll get it running. We'll show you all the components and all that stuff, and kind of tell you what they do, even from the classroom perspective. How many of you guys have a little bit of an air conditioning background by any chance? A little bit? That's okay. Well, we're going to teach you a little bit about it, okay? We're not going to get into looking at freaking, formulas and all that stuff. We're going to talk about what's going on a machine, okay? What you need to look out for, too. And also watching for best practices for piping, electrical, stuff like that. Because if you don't have the proper flows through these, water flow, can you damage a machine? Yes, you can, okay? So we'll talk a little bit about that. Now, we've already done the introduction phase. So thank you for introducing yourselves and telling me where you're from and all that stuff. Now we're going to get into installation. Installation on any piece of equipment is very critical. So you have to follow proper guidelines, okay? So before we get involved in the installation, you got these manuals in front of you, okay? So these manuals here have tabs, okay? So if we take a look here at the manual, let's go ahead and take a look at this. The first point is the PowerPoint, so you can follow along with the PowerPoint. The next tab is a ICOM 6 book. If you take a look here, hold that open, you can see that ICOM. That stands for Installation Operation Maintenance. So let me actually push this down here, pull up the manual, and I'll explain a few things about our manuals for you. Okay, let's go to page 1 here. Okay. Let me just reduce this down just a tad. Move it over. So if you take a look here, you can see that this form here, ICOM 6, Installation Operation Maintenance. This manual should be with the machine when it first gets installed. It should be in one of the control panels. But the installing contractor should be leaving it for you. But also, they might need to they should already have a copy of this manual too, so they can actually look at the installation procedure and follow best practices, what we recommend. So have you guys been involved in projects already with the machines being replaced or installed in your career? Okay. All right, cool, cool. So have you ran into any situations where, you know, they didn't follow some of the best practices?
I mean, I've seen some, I've seen you
Questionable?
Yeah, questionable.
Yeah, so one thing is, so this is the installation operation maintenance. Let me explain this column for you. So this here, this is what we call a form number. So this form number allocates what type of equipment this is associated with this manual, okay? So you can see a date code here in these parentheses there. That there is basically 8/17 is when that was actually produced. If we come back over here, let me scoot over to the right a little bit. You can see here, this actually changed at 12/17. So if they add something to the machine, or they add something for troubleshooting or maintenance tasking or whatever, in the certain sections of the book, you'll be able to actually, when you're looking at the actual pages, just to give you an instance here. One of the guys was asking me a question on a machine that he's got in Honolulu, and for a different machine, and I said, here, give me an email and I'll send you actually some documentation explaining what he's seeing as far as an alarm on one of his machines. So he asked me for some guidance. I said, sure, I'll give you a hand. So, yeah, so it's all good. So this is the ICOM 6. The next manual that we see here on the next tab is going to be NM1. If you take a look at it, the next tab, it actually stands for Installation Operation Maintenance. Well, we're talking, we could still use this manual here for installation operation, but if I need to find out the maintenance tasking, I can actually go to this manual and look at the maintenance section and look at the maintenance tasking that's required. So that's an ICOM 6. So you can actually see operation maintenance and then also operations for the ICOM. There's one more manual here. There's the engineering guide. So the engineering guide here, since most of you are engineers, this might be a good book for you to actually look at as far as, let's say you're looking at flows, okay? Let's say minimum GPM, maximum GPMs, what about motor design? Because again, this is like 64 pages. But actually, let me actually blow this up here. When you start taking a look at the actual model number here, YLAA, your air-cooled chiller, Series A design, 4-digit unit number, 0125. You can see here for the efficiency, standard efficiency. So again, I'm on page 2 of the engineering guide. 46 is the voltage code, so this is a 460 volt application here. We take a look at the refrigerant here on this character here. So we count them over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Number 12 would indicate this is a type of refrigerant that's associated with the machine. Also the design series and development here for brazed plate heat exchanger. So the brazed plate heat exchanger is what we have on this machine. This machine can also be outfitted with basically a tube and shell barrel, okay? So this is a flat plate. It's doing the same thing, but again, different applications, okay? So we got the engineering guide. The next thing is for startup and commission that we will look at towards the end of the class. So more than likely, we're going to spend the duration of the class going in and out of the ICOM 6, okay? But you've got some other resources if you need to look at them, okay? Now, sometimes I lose this thing every now and then. I try to keep it next to me. Now, here's some of the requirements that a technician, when they're following a startup or when it's being installed by other contractors. Location and clearances. Location is very critical for this machine, okay? When we're talking about location, we don't want it in direct sunlight. But also, is it on the roof? Can the roof structure handle the load bearing of the weight of the machine, okay? That's critical, okay? So you might have to get a structural engineer involved. You guys are all mechanical. Have you guys ever dealt with structural engineers? Yeah, good deal. Because you want to set something, you want to make sure it stays up on the roof instead of going through and possibly causing some damage or death to people, okay? Now the foundation, okay, now again, the foundation, we want to make sure it's level as possible. Ground level locations, you know, when we mount them on the ground level locations, make sure that that concrete's not actually associated with the actual building. So hopefully, won't that attenuate into the building, vibration? Yeah, so it's another thing, okay? Rooftop locations, they can be put on roofs, but again, we got to make sure that they are structurally sound to handle the load requirements. How about noise sensitive locations? Could be a school. Could be some lawyer's office and stuff like that. With that case, we do have options for these machines to buy sound blankets, because scroll compressors can be somewhat substantially loud, okay? Especially when they first start up, and then they start to settle down, right? Then they start to get more refrigerant coming back to them, okay? So we might have to put some sound blankets on the compressors, also maybe get some sound attenuated panels to help condition that sound, so it's not harming somebody when they're concentrating, school as well. Not only that, animals at night have very sensitive, aren't they? So certain pitch sounds will make dogs bark all night. So there's some sound laws in some cities that you gotta follow, okay? Now, the spring isolators, when we get out of the machine, spring isolation is very critical on any application of a machine, because if we don't have the spring isolators underneath the machine, could that present some possible damage to the machine? How about refrigerant leaks? So if you were to just mount this thing on a concrete pad without putting these on isolators or what have you, or pads, who's going to take up the vibration or the starting torque when the fan starts or the compressor? The equipment is, right? So that piping, could that piping get stressed prematurely, crack and everything else? Now you got a bunch of refrigerant leaks. And again, you patch one leak and have another leak. That's like doing one patch after another patch after another patch. So again, if you see where you're getting a lot of leaks, you might want to take a look at the application, make sure they got it set up correct. Okay? Now compressor mounting is also critical as well when a compressor is being changed out. Chill liquid piping, the sizing of the piping. You guys are mechanical engineers. You guys get involved in piping sizes? Yeah, especially depending on the tonnage, right? Yeah, because that's going to tell you how much water you can go through that pipe, right? Yeah. So also, many systems from other manufacturers, from other installing contractors, we've seen machines pipe backwards where the outlet is on the inlet and the inlet's on the outlet. And when you get out to the job, before you start up, you tell the contractor, hey, this machine is not piped correctly. Boy, you will see them doing backflips, but it's not a positive backflip. They are ready to boil over, right? They're upset because now it's going to delay the job. General contractor wants to get paid. Well, now the installing contractor is going to flip his lid because now the change order, right? You guys see change orders, don't you? You don't love them, do you? But I don't think anybody likes change orders. And again, pipe work arrangement. So again, the piping has to be done. How about supporting the piping for pipe stress? Is that critical? Making sure it's hung correctly, the piping's being supported correctly. Chillers or equipment is not supposed to support the piping now, is it? No. It's got to be, when we look at this machine here, when you look at the I-beam, you're going to see a piece of all thread and everything else that's welded on there and adjusted for the piping to be supported. Take a look at that. This is one way of supporting, but you would see proper pipe hangers and stuff like that supporting a lot of your piping. Okay? So it's critical. How about the wiring? Is wiring critical? Wire size? That's all going to be determined by the ampacity, right? How many amps are going in the machine? Now, anybody electrical here? So yeah, so electrical. So this is right up your alley, huh? Yeah, do you carry an uglies book? No? Okay, well, I do because I'm not but I can look that up, right? Boom, boom, boom. Look at the wire size and all that stuff. Because wire size is critical. You don't have a proper wire size, it's a big resistor, isn't it?
It catches on fire.
It'll catch on fire, or the insulation is going to melt, right? Then you can have arcing between phase to phase. Yeah, yeah.
Especially on power lines.
Oh, my brother worked on the utility lines at one time. He got off of that, and now he does all the meters and everything. Still making the same money. Yeah, system run contacts. You know, again, if we want to incorporate them from the automation to actually see if the system would run contacts, alarm statuses, remote start and stop contacts, remote emergency out. We don't have that, but that can be tied in. We could actually go in there, maybe put a mushroom switch or something like that, maybe on a chiller plant, get that mushroom switch basically for emergency shut off to kill it, or we can also set something up inside the machine for an emergency shut off. There's a set of contacts that we can actually close, boom, shut the machine down. The emergency shutdown on the switch is the rocker switch on the actual interface. That is not to be utilized unless it's a dire emergency, okay? All right? So, when we take a look at the installation checklist form, 150.72 CL1, that's not in any of the books, but this is what our mechanics will get. Our mechanics will get this after this is actually filled out by, let's say, all the skilled trades involved with the install, okay? Let's say the electrician. How about the controls contractor, since it's got automation? How about the piping mechanical company, okay? How about the insulators? Yeah, so anybody that's involved with that job, for that chiller install, that's all gonna be signed off, checked out by them. It goes back to the general contractor. General contractor sends it to the local branch that's gonna facilitate that startup. He or she is gonna have that in there. If it's been pencil whipped, falsified, that's what I mean by pencil whipped, that if somehow it's been pencil whipped and that startup technician goes out to the job site and they find things weren't done correctly, they're gonna put it out there. They might reject the startup. And please don't be mad at them if they reject the startup. The fact is they're trying to make sure the job's installed correctly, but also meeting safety criteria, because again, let's say they didn't have the proper ground in there, right? Ground size water, right? Somebody goes up there, you got a compressor that's shorted out phase to phase, right? And it's energized. They go touch that panel, what do you think's gonna happen?
A lot of things.
A lot of things are gonna get electrocuted. Hopefully you're not gonna touch it with two hands where it goes to the heart, possibly collapse, okay?
Hopefully it just doesn't blow up.
Yeah, or
Box
blow up,
and
right?
incinerate you,
Yeah,
so-
incinerate, yeah, because again, you can turn into ashes to ashes, right?
Arc flash.
Arc flash, yeah. If you ever get arc flash where your eyes are burning, here's what you wanna do. Take your raw potatoes, scallop them, okay? Put them on your eyes and lay down. That'll get rid of the flash burn. A lot of your welders that arc weld, they get flash burn because again, they're always holding up the hood and everything else. Anybody snow ski? Snowboard? Yeah, you go out there, if you don't have the bright goggles, are your eyes gonna get burned? How, anybody fish? Boat? Same thing, if you're on the water, you gotta be careful, you gotta have a proper safety, right? Now, the following items through 1 through 6 must be checked before placing units in operation. Inspect the unit for damage. Here's another thing too. With the contractors that are actually gonna be receiving this equipment, before it comes off the truck, they gotta inspect it for damage, because once it comes off the truck or the trailer, while it's being delivered from the factory, it hits the ground, it's yours basically. And if it goes up on the roof and the startup technician, he or she sees there's damage, they gotta write it down. Then they gotta get a hold of the salesman, the office and all that stuff and let them squash it out. Let them pull the penalty flags, let them deal with, the hierarchy to figure out what they're gonna do. But more than likely, the mechanic's gonna get basically chastised by the general contractor, the mechanical contractor. Oh, you gotta blah, blah, blah. Sorry, I can't. I gotta go through the proper channels. So, just some things to think about here. Well, now, how about rigged a unit for using spreader bars? Now, spreader bars, the reason why we say proper size spreader bars is because we're worried about the length and the width. So we gotta make sure we have spreader bars that are wide enough, spreader bars that are long enough, because of the frame of the machine. Depending on the length of the machine, we're gonna have different pick points, okay? To pick this unit up and rig and actually install it so it's basically nice and level and square. Because again, if you pick this up and the cables are interfering and all that, you don't have a proper spreader, it's gonna torque, it's gonna twist, it's gonna bow, it's gonna buckle. That happens, is that gonna affect the actual, when you go to set the chiller? How about the coils and the piping? Is that gonna be damaged? Is it gonna be bent? Is it gonna be fatigued possibly? It's gonna lead to a lot of leaks as well, okay? Now, one of the things is too, is making sure that they're following the ASHRAE requirements for proper piping practices. You guys know all the ASHRAE rules? Probably not, right? But if you had to, look it up. There's certain piping practices that have to meet requirements in order for it to be piped correctly, okay? Also, how about the wiring? Make sure it's tight and meets the National Electric Code, because loose wires lead to a lot of heat, don't they? A lot of arcing. Yeah, I like talking to electrical guys because, they're like, yep, I've seen this, I've seen that, yep.
I worked on paper mill for a while.
Well,
Some
paper
interesting
mill
things.
too, and guess what? That paper gets up in there, right? That becomes flammable
We
airborne.
do all sorts of things.
Oh, yeah. I've worked at a lot of paper mills tearing down chillers, okay? So when you go to pull a burn permit, guess what? You gotta have a fire watch and everything else. So I've been there, okay? Also, check to see the unit is installed and operated within limitations, okay? So that's criteria as well. Now, clearances, but before we do that, we're gonna get into here, we're gonna talk about some of the rigging. So, again, I got some notes in my manual here. So what we're gonna do here before we actually get into some of this stuff, what I want to show you guys here, on the ICOM 6, okay, let me actually, both the ICOM 6, ICOM 6, we're going to go page 20, from 20 to 23. So let me actually type in 20. Because some of you guys have probably never seen this machine, or seen one of these. But let's say you got a new machine and you wanted to check out and just see what the layout is. So what I usually try to tell new people that are getting associated with these machines is to come over here, take a look at the layout. So on page 20, we take a look at these items here. So number 1 is pointing at the condenser fans. Number 2 is pointing to the microchannel coils. Number 3 is pointing to one of the control panels. And we take a look at number 5, 6, and 4. Here's the actual legend here. Fan assemblies, microchannel, control panel, compressors. So if we take a look at number 4, these are all the compressors. The one thing about these compressors, how they're piped tandemly, meaning they got a common suction and discharge line. So I could have 3 or 2 compressors on one circuit. Okay, there's 2 independent refrigerant circuits. So with that being said, on circuit number 1, on this machine here, we got 3 compressors. On circuit number 2, we got 2. That doesn't mean I need to bring on system number 1, compressor 1 at that time. I can bring on number 2 or 3 on that circuit at any time. Number 3 could be the lead of that circuit, or number 2 or number 1. They're looking at hours and starts. Same with the other circuit, number 2. Okay, so that's how they can do that. All right, so now you can see the control panel number 3 here. And again, on the control panel, over here, this is your utility power. Over here is your control side, okay, where the human interface is. Okay? As we continue, you can see receiver included with optional heat recovery. We're not seeing that. Filter dryers. Number 6 here. Why do you think we have filter dryers in the system? Some of you guys don't know a lot about refrigeration, which is fine. The liquid line filter dryers are there to take out any moisture and any other stuff that's in the system, the refrigerant system. So it's there to clean it all up, okay? And every time the machine's opened up or whatever, they need to be replaced regardless. Meaning that change out a compressor, you do some service on the refrigerant circuit, they need to be changed out. Yeah, let's go to the next page. Now we can take a look here. You had to get a walk around here. New to you, use this portion of the book to get acquainted with the components. You can see here, number 1, here's the fan deck, so there's where all my condenser fans are. You take a look at number 2, there's the microchannel heat exchange. Microchannel coils are made out of aluminum. Aluminum on aluminum. When you're cleaning them, do not use any chemical cleaner. If somebody's using chemical cleaner on their condenser coil cleaner and all that stuff, it will ruin them. Okay? Now you can see the coil headers here on number 4. They're talking about these guys right over where my mouse is. That's the headers there for your actual discharge gas and your liquid line coming down. The braze plate heat exchangers right here, number 6. That's this guy right here where my mouse is. So you can see at number 6, that's where you're going to hook up your inlet and outlet water. You can see here down where my mouse is here, there's a connection there and a connection there where my mouse is hovering. And if we take a look here at base rails right here, this is the base rails that they're talking about here, number 6. There's the hydro pump kit here, number 8. So over here where my mouse is, that's the hydro pump kit. So that's an option to make sure that we have good flow through the evaporator at all times, okay? Now, let's see if there's anything else. This is the layout of the panel right here. So if we were looking at this, you can actually ID all the contactors, everything else. Fan contactor, fuses, fan contactor, disconnect switch. So this is inside the panel. So if I had to walk around here, get an idea on all these elements right here, this is a good place to search right here. Okay? Get associated. Let's see here. Location clearances. Page 88. So we're going to jump to page 88 in the same book. 88. Now, these are the minimum clearances that are needed for this machine. Okay? When we're looking at this machine here, you can see here from side to side, you're looking at 6 feet. From the back side here, this is 6 feet. Up here in the front side, this is where the control panel is. You need 4 feet. So when you're looking at some of the stuff here for the isolators, when they're telling you left and right hand side, even for rigging, you're going to look at this right here. This is the appropriate place. Okay. So also, There's some notes down here for best practices for installation, okay? So, no obstructions allowed above the unit. Only one adjacent unit wall may be higher than the unit. Adjacent units should be 10 feet apart, spaced apart. So, you got machines sitting side by side, you're not gonna pace them 5 feet apart. So at least 10 feet, that's the what? Minimum requirements. A little more is even better. Why do you think they want proper spacing?
Get airflow.
Excellent, good job. Excellent, because again, if I'm discharging out of one machine and it's closer, you're gonna be picking up that heat that's being generated because you're rejecting heat out of the fans, right? You're sucking that ambient air, changing the condition of that superheated vapor back to a liquid, okay, through the condenser. And what happens, that air is picking up heat and it's gonna be driven over, and the other fans on the other machine are gonna be sucking that air in, and it's gonna raise that pressure and temperature as well, okay? So you may not be able to hit your target from your set point because again, you're overloaded possibly, okay? So requirement, space requirement is very, very, very critical, okay? Rigging, let's take a look at page 32. Now, when you look at the rigging aspect of this right here. Now, different manuals gonna have, like this is a 4-fan unit, so when you're looking at the control panel, again, rigging from C, A, B, C, and D, they gotta make sure that they hit these points right here, okay? A, B, C, and D here. If I keep coming down here, there's some more pick points here for a 5 to 12 fan unit, okay? So here's a pick point here, so you got the proper spreader bars. Gotta make sure that they pick them up in the proper spots for rigging, okay? So we don't twist or buckle. Now, when the crane company or the rigging company is lifting this here into place, they can use shackles or we can use container lugs, okay? One of the things about the container lugs is that they can lock into place. Shackles, you're relying on them to go through the hole, making sure that, you know, the hardware's in there, right? So again, more than likely, the crane company will probably, they should be providing all the rigging, shouldn't they? Okay? One of the rigging contracts. So this is talking about how to properly rig this machine back into place so where it's actually set up correctly. Okay? Okay. I'm going to jump back into the PowerPoint, gentlemen. All right. Take a look here. Here's a note. A motor insulation life drops by half for every 18 degrees Fahrenheit over temperature. Okay, so if we're running these machines over temperature, because again, let's say we're short cycling that air, you're picking up that heat going through those little condenser fans. Could it actually destroy those condenser fans? Yeah, because again, they're relying on the air to come across those fan motors. They're totally enclosed air over fan motors, okay? So what that means is that they're relying on that air to cool them down. So that raises the temperature. More than likely, you're gonna have a lot of motor failures as well in the condenser fan arrangement. Now this is a 6-fan arrangement. The one that we have out there is 5 fans. You'll see one here, one here, one here, one here, and one in the middle, just like your dice. So if some of you guys play craps or Yahtzee or whatever, just think of the number 5 dice, okay? Now, take a look here. Take a look at this location. When you look at this slide here, what do you see very disturbing here, or what's incorrect? No clearances, but it's in a parapet. How are you going to exhaust that air? How are you going to service that? How are you going to get the compressors out of there? You're not. More than likely, if that machine goes, it's going to have to be replaced. This is out somewhere in the Middle East somewhere, okay? You're going to see another slide. Take a look here. Look at the top of the condensers and all. Look at how foul they are. That's a pretty dirty environment too. But yeah. Look at that. Are all the walls higher than the unit? You're not going to have components that last for long like that. Compressors are going to fail. All kinds of stuff are going to fail.
It's trapping all the heat.
Yeah. This is not an oven. It's a chiller, right?
Yeah, we ain't doing nothing.
It's being converted. Yeah. Now take a look here. Here's what I like. So I feel sorry for the guy that's got to climb down this Widowmaker ladder right here. Now, does this meet OSHA requirements? I would say not, but other countries, you know, they don't follow some of the guidelines, and could this be very dangerous for someone? Yeah, for any individual. Can you imagine getting stuck behind here or something like that? Let's say you're rigging something out of there. Do you have room to get out of the way? Yeah, let's say if they were to lose something, they're rigging it out of there. Let's say for some reason you're pulling a condenser fan motor off here. It gets loose. Do you have room to get away, to run out of the way? Probably not. You don't have a lot of room, do you? More than likely, could that be a safety hazard too? Yeah. Now, remember, using the proper lifting lugs here to actually lift this and chill in and out, okay? So again, you can use shackles, but remember, the pick points are what is very required when you're lifting these machines, okay? The lugs should be attached to cables or chains using shackles or safety hooks. Now, you can see here, two pictures here. One's the correct way, one is the incorrect way. So if you look at these cables where they're actually coming into one point right here, you're going to see these cables are changed where they're actually what? Coming against the condenser coils and the equipment. Is that going to actually destroy the equipment? It sure can. Now if you take a look at the proper spreader bars and everything for these pick points right here. So you got 2, 4, 6, 8, 10 fans on this. So you can see the pick points here. Bam, they got the hole requirements there. That's how you want to pick them. So, so hopefully installation mechanics that are actually facilitating the installation practices follow these guidelines. So if you guys are monitoring a job, since you guys are, working for the Army Corps and you're involved, do you guys ever get involved as far as looking at some of the installations, making sure they're going good? So is some of this information helpful? Because you know what, this not only parallels not only to our equipment, but you guys might be putting a train unit in, a carrier unit. We follow the same guidelines. I mean, a lot of us follow the same guidelines, every company. They might have different pick points, but still, we want to make sure, okay? All right. Now, we talk about spring isolators. So you can have elastomer, which is this right here, or else you can have 1 inch or 2 inch. Now, take a look at here, the location of these isolators. One thing about these isolators, it's pretty cool here, these have to be spaced accordingly. And we'll take a look at the sales order from the mechanics that when they do the startup, when we get towards the end here. But you notice this color of these springs here? That's a purple spring, isn't it? Guess what? That color of that spring there is associated with the weight that it's actually, where this is positioned, how much weight's in that section of the chiller. So these color of springs actually dictate the load variables, how much weight they can sustain, okay? So when we look at the sales order, pretty soon here, you're gonna see where they allocate this part numbers, and these springs have to be associated. So you're gonna walk out there, you're gonna see 4 gray springs and 2 green springs that were sent with the chiller when we got the spring isolators, and they had to be set in there properly as well. So they have to follow the guidelines. Okay? Now, let's see here. Page 8. Let's see. I'm going to jump back to the icon 6 here. Let's take a look here. So we're going to get in over here to, we'll go back a few pages. Sorry about this, gentlemen. So let's start at page 80. So you're going to see the dimensions for 4 fan units right here. But not only that, when you start taking a look here, you can actually see the layout. Let me actually blow this up a little bit here. So depending on the model number, you can use these guidelines here, some of the measurements, okay, as far as lifting eyes as well, okay? But also where the brace plate, flat plate heat exchanger is, all the component layout for the different fans where the connections are, okay? Now take a look at some of these notes here. Placement on a level surface of frequent obstructions, including snow for winter operation or air circulation, ensures that the rate of performance is reliable. Okay, let me shrink this down so I don't have to. Let's see here. Operation and ease of maintenance. Site restrictions may compromise minimum clearance indicated below, resulting in unpredictable airflow patterns and possible diminished performance. Johnson Controls unit controls will optimize operation without nuisance high pressure safety cutouts. However, the system designer must consider potential performance degradation. Access to unit control center assumes the unit is no higher than no higher than on the spring isolators. Recommended minimum clearance, sidewall 6 foot, rear wall 6 foot, rear to end 4 feet. No obstructions above. Between units, 10 feet. 10 feet, no more than one adjacent wall may be higher than unit. Then we start looking at 4 fan units. Okay? And you can actually see all the dimensions right here. Okay? So depending on what machine, here's a 5 fan unit that we actually have out there on this installation. So again, just showing you here all the different items, okay, for all the locations. 6 fan units, 8 fan units. You can see, doesn't it grow the actual length of the base and everything else? Yeah. And again, as these machines increase in tonnage, gotta make sure that they're actually set up correctly. Then you can see all the rigging points from here. And when you're looking at these dimensions right here, let me blow this up a little bit so we can actually put our eyes on it. Sorry that the print's very small, but there's your rigging points right here. See all right here? So depending on your machine, size of the machine or your model number, the actual installing contractor should be looking at this with the rigging company, okay? So I just want to point out some of this stuff here. Now, let me decrease this here. Now we're going to get into some of the isolators, mounting, weight distribution and isolator. So depending on the weight, you can see here from left to right. Now take a look here. Right here, if we take a look, let me see if I can pull this up. Right here, you can see here, R1 to R2, L1 to L2 depending, but you can see here, they're giving you the distance here for the X dimension, the Y dimension, as well as the vendor number and the color of the spring, and also the operating weight as far as the load characteristics and what the springs are allocated for, okay? So if an installing contractor needs to know where these springs go, they can actually go to this section of the book and get a good idea. And then again, if they need to go back here, 4 fan isolators, you can see here, page 89, keeps going down here. So when you're looking at these point of connections, remember, right and left-hand side. So let me blow this up here just for grins and giggles here. So I got an isolator going here, isolator here, isolator there, okay? So just showing you here that they can actually take a look at this here. This is all relevant of the model number. So you can see here, here's the dimension from here to here, and again from here to here, from here to here for the isolators. Make sense? Okay. Let's go back into the PowerPoint, okay? So going into the PowerPoint, so we discussed the isolators. Not only that, when they get mounted, they have to be set up correctly. So the installing contractor has to make sure there's some deflection. Because if these aren't deflecting, how is it going to absorb the vibration, right? It's like a resilient valve, so yeah. So again, looking at the portion of the book here for allocation, where these springs need to go, but also, when we look at the sales order, we'll be able to determine where these springs need to go as far as A, B, C, D, or what have you, these locations, okay? Now, what about installation here? This is best piping practices here. When you take a look at your inlet and your outlet water here, this line right here can be very critical and very helpful. This is what we call a bypass line, okay? So this is recommended best practice piping here for, this is a DX barrel right here. This isn't a flat plate, but we're gonna look at a flat plate piping, very similar to this. This bypass line, these isolation valves too here, we can isolate the evaporator here and basically flush the system out, okay? For, let's say, new install. Okay? When they get done putting all the chill water piping, condenser water piping, they should be flushing that, shouldn't they? So what we're trying to do is eliminate any debris as it's being flushed to get entertained into the actual barrel, because if we get a lot of buildup, a lot of crap in there, it's going to destroy the evaporator, it's going to plug it up. And we're going to have what? Insufficient water flow. Would that be a true statement? Okay. Now, let's go back to the ICOM 6 and we're going to look at basically page 37. Okay, so let me jump into page 37 real quick. Now, on this page right here, this is what the piping looks like, but this is a brass plate heat exchanger that you're seeing on smaller tonnage chillers now. It's cheaper to make, but again, it's doing the same process right here. So again, we can bypass the flat plate heat exchanger. Now, one thing is here, this is very compact. So, could there be a potential debris getting in there and really plugging up a flat plate? Because again, basically, you guys ever seen a flat plate heat exchanger? Yeah, because you got refrigerant on one side, water on the other, and they got these plates, right? Okay, if they start to split or whatever, we can start entertaining water and refrigerant on the same side, which is not conducive. Okay, water on the refrigerant side is not conducive, which can lead to a lot of component failures. Okay? So again, we talked about the piping too. That should be supported. Okay. Let's jump back into the actual PowerPoint. Okay. Now again, if we take a look here at the design working pressure, it could be 300 pounds, okay? Now, the flange accessory, depending how it's ordered for the actual, well, they're talking about a flow switch here, but as far as how the connections are, okay? Now, take a look here. How about flow switches? Do you guys know what the purpose of a flow switch is for? Just like it says, make sure we provide flow, right? Because if you don't have flow through the heat exchanger, I don't care if you're using the boiler. Some of you guys already been out there with the other guy, right? With the boilers and everything. Did he talk about having proper flow? Yeah. Now you push through a chiller, you pull from the boiler, okay? For piping when you're pumping, okay? So one of the things is, this is a DP switch. This can be utilized as far as validating flow through the closed loop as well, even on the open loop for condensers as well, if you've got a water-cooled condenser. But this DP switch would be utilized because I could not be able to put a paddle switch. This is on a horizontal plane. This is because if we got 290s, we don't have enough long and straight run, we can put a DP switch in order to actually make sure we validate flow. So it's on one side on the inlet, one side on the outlet, but it also has to be adjusted, okay? This paddle switch too needs to be adjusted as well for the minimum flow on this as well, okay? This is a paddle switch. If this was installed over here closest 90, okay, not going to work because again, this is on the outlet. Okay, so your outlet on it is on this side here for the actual flow switch. If I put it over by this 90, what's going to end up happening is that water is going to be hitting this 90, and that paddle's going to be doing this bam, 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 on off, on off, off. Now, if a paddle switch is on a vertical riser, how much does 1 pound of water weigh? 8.33 pounds. Okay, so if I'm on a vertical riser, okay, I could have 1,000 gallons in that loop on that riser. Think of the weight that's on that pressure or the paddle switch. So right now, I got all that static head setting on that paddle switch. Do you think that paddle switch could break prematurely? But not only that, it's going to be down. So when that pump starts, it's going to come up and it comes down when it shuts off, right? That's a lot of weight on it to overcome. Would you agree? So that's why you do not put a flow switch, a paddle switch on a vertical riser. And when you guys go to some of your places, you might see a flow switch on a vertical riser. And if it's failing prematurely, that's because it's on a vertical. They're out there, okay? But we're incorporating a flow sensor. Okay? Now we're going to be talking about, but we're also talking about flow as well, okay? This is the formula right here. Okay, what I'm going to pull up here real quick here, since we've been talking about flow and everything else. Got another document here. This here is a document that actually goes to the startup mechanic that's going to be would perform a startup at the job site. Now that's that handout that's in front of you guys right there, the little piece that's like 4 pages, but it's printed on back both sides. Now this is for this machine here. So when you're taking a look at this, you can see here the unit, the project name, the effective date for the manufacturing, as well as order revision number, but the unit tag, the model number, the capacity here as far as the tonnage, the voltage, and the refrigerant type. Now, these are the pins here that we actually broke down here through the actual model number. But here's my evaporator, here's my design criteria. So my entering water temperature design is 54 degrees. My leaving water temperature that's designed for this machine, again, when this machine's running, we're trying to output to 44 degrees, okay? But we got to make sure that set point's in there for even chill water temperature. Now take a look here at flow. This is the gallons per minute, so we're looking at about 199.6. Take a look at your pressure drop. Wait a second, what the heck happened? Oh. We had this the last time. Must have timed out. Well, anyway. So you see here pressure drop. That's 6.99 feet ahead. Now this formula up right here, you guys probably know this. 1 PSIG is equal to 2.31 feet ahead. So, let's say I had a column of pipe, and I filled up the water level to 2.31 feet. If I put a pressure gauge on there, that's going to represent 1 pound of gauge pressure. Okay? Now, when we're looking at the inlet and outlet, looking at the pressure drop is critical to make sure that we have the perfect flow through the machine to meet design criteria. Okay? So, we'll make sure that's adjusted on start to maintain this actual pressure drop. Okay? So when you're looking at this pressure drop in feet ahead, you got to take this value and actually take the 6.99, divide that by 2.31. That's going to give you your gauge pressure drop, okay, your delta P. Now, this here, let's say this here is 1 foot ahead right here. So if I got 1 foot ahead right here on this particular guy right here, let's say I fill up the pipe right here to 1 foot, okay, 12 inches. So I put that level there. If I look at it right here, put a gauge on there, it's going to correspond to 0.433 pounds per square inch gauge, okay? So when the guy's starting this up, they either take that feet ahead right there, pressure drop feet, H2O 6.99, divide it by 2.31, or multiply it by 0.433. Because if I take 1 PSIG divided by 2.31, it comes up to 0.433 as well, 0.4329, but we just round it up, okay? Now, fluid type that's going to the machine is water. Does it say brine application? No. Brine application would be some type of glycol, whether it be propylene or polypropylene glycol, okay? The pink stuff, okay? Because that's good for food grade and all that stuff, all right? Okay? But we put in the other stuff, you know, it's, again, depending on what it calls for. So, that's going to tell you the fluid concentration. So if this had glycol, they might see a factor in there of 30%. You guys ever seen glycol systems? Yeah, so that glycol there changes the freeze protection, doesn't it? Right? So if you're going below 36 degrees, depending on the application, but also air cool, your outdoor environment. Let's say, depending on your climate conditions, can it get relatively cold and freeze in the winter, but you're running this machine 24/7 at a hospital, a data site, what have you, depending on the application. You guys might have some criteria where machines run 24/7 with some of the facilities that you guys govern. Would take that into account, or whatever you guys are working on, right? Yeah, so some good stuff. Now, if you have too strong concentration, guess what? If you go above the concentration, you derate the tonnage of the machine, by the way. So if it called for 30 and you put 50%, more than likely you're probably gonna lose the tonnage because it's thicker, it's heavier to pump, so your evaporator, your chill water pump that's pumping may not be sized. You might be going off on high current and all that. Pump motor starter and all that stuff's probably gonna trip and all that stuff because you're going above the current. It's taking too much horsepower, too much work to pump that because it's too heavy. Okay? Now, ambient air temperature. So again, these machines can run up to 112 degrees before you start derating them. They still run above 112, but what will happen is it'll start to possibly lose. You probably won't be able to achieve your set point, especially if you've got an intense load on here. Okay? This is the hydro kit. So you'll see a hydro kit. There's a pump on there. Tells you total feet ahead here, 37. Pump kit, external pressure drop. Again, you see here 20 pounds right here. So you can convert that as well. There's the pump load. Take a look here. These are all your isolator weights right here. So take a look here. Number 1 here, left-hand side. So when you're looking at the control panel, left-hand side would be the left-hand side from the control panel, right. So you can see here, this calls for basically 3 springs on each side, but take a look at the load variables. So the installing contractor would have to take a look at those springs, right? We look at the table for the weight distribution. They select those proper springs and make sure that they go in the machine, correct, at those appropriate locations that we've covered, okay? Now here's another thing the startup mechanic must also look at when they're performing the startup. They're going to be looking at here all the options here. Okay, these are all the kits here, low ambient kit. Again, this is gonna be programmed for English. Again, service isolation valves, we got service isolation valves all over that machine. Hot gas bypass on the number one circuit. And again, making sure we meet mechanical engineers vessels associated codes, thermal dispersion flow switch. All aluminum microchannel coils, no heat recovered, wired louver enclosure panels that we have on the condenser, low sound fans with VSD control. Okay. 1-inch deflection isolators, Hydro Kit L, variable speed drive, full feature mechanical kit, single pump. Again, warranty right here. Okay. From shipment or date of startup, whichever expires first. Unit parts warranty 30 months, 2 years. Unit labor warranty 30 months, 2 years. Now, my understanding is that you guys might have some different warranty that you guys basically utilize for the Army Corps with some of the contractors. But again, this would apply to the public, Joe Public. But again, you guys are we're probably, other manufacturers probably meeting some of the specifics that you guys need, okay? But in the civilian world, okay? We'll say civilian. Now, let's go back into the startup section, okay? Now, one of the things is that a startup mechanic from Johnson Controls, he or she will be performing this. There's some pre-startup procedures that need to be followed. No power. We'll be checking a lot of stuff here. The wiring. Checking to make sure it's torqued down, right? How about pull and tug method on the control boards, making sure there's no loose wires coming out of the terminal box? How about inside the control panel? You got somebody that's been running electrical and they got all these little whiskers in there, copper whiskers in there from, you know, when they're stripping the wire, the insulation. All these whiskers are in there. Could that get airborne? Can it get airborne? And then it goes through, let's say, a solid state electronic board. Could it actually short it out? How about also landing on contactors going from one phase to the other depending on the whisker, right? So these are just some of the things. A lot of electrical contractors that like to smoke and dip, sometimes they use that control panel as an ashtray. Seriously. Cigarette butts laying in there because they don't want to put them on the membrane roof, right? So, yeah, we see that quite a bit. Also, so we're going to talk about some of these procedures. Now, another thing is our staff, the startup technician also has to complete the startup documentation, and then possibly, if they can't meet the let's say if we try to start this machine up, say last week, you guys weren't here last week, but it was very mild. We were in the conditions of about 46 degrees, 48 degrees. Last Friday when we started this up, we were putting jackets on, me and the startup mechanic, because it was cold out. We couldn't get a load on this thing. So we're gonna wait for it to actually warm up. So I said, document your startup documentation, I wanna see it. That you're gonna come back out here when it warms up in the spring and actually restart this and make sure that we can actually do the tonnage. Because when we're dialing this in, I wanna be out here doing the tonnage calculations, GPM formulas and all that stuff, figuring out the tonnage that's going through this machine. We're gonna load this guy up, okay? And again, that's what we talked about, post-startup. Now, one of the things is too, we got a checklist that needs to be filled out. So when the startup mechanic facilitates that, finishes the startup, they'll send that in. And because again, that's gonna also, in order for the warranty to be valid as well, that startup documentation needs to go back to the factory. Here's another thing. If you guys have some of these machines, with any machine, they give you to start, make sure you get a copy of that documentation. For the sole fact is, you got record of it, okay? Not only that, let's say if they need to actually reprogram this and all that, the startup paperwork documentation's got all the actual set points, all the cutouts and everything else if they fill it out. Because again, if you have to reprogram this, you lose an EEPROM on there, okay? We call it the BRAM, battery random access memory. It holds all your set points, it holds all your history and all that stuff. You put a new EEPROM, it goes to standard defaults, it has to be reprogrammed. So some of the standard defaults may not meet your guys' site requirements for temperatures and everything. So again, also program values, so make sure that's there, okay? How about arc flash? Now, again, this is right up your alley, arc flash, right? We talked about that, but take a look at some of the intensity here. Hazardous flash can occur in any electrical device, regardless of the voltage in which energy is high enough to sustain an arc. This includes many 440 volt motor control centers, panel boards, and switchboards. An arc of this type will, while typically less than a second in duration, can reach temperatures in excess of 14,000 degrees Fahrenheit, high enough to produce extensive first degree burns and permanent blindness or death. Now let's jump on a 4160. That thing starts to act, you're gonna disintegrate. You ever heard that David Bowie song? Ash to the
There's
ashes,
a YouTube
dust
video.
to dust. Yeah, that's not good. Become atomized, right? Yeah. Now, one of the things is a good philosophy to follow with any company that's doing a startup on a piece of equipment. Assume nothing, test everything or check everything, okay? One of the thing is power off check. So the startup mechanics can look for any damage. We talked about damage. Because remember, if it came off the truck, they put it up there, mount it, guess what? They're gonna have, if there's damage apparent, the startup technician is gonna note that in his or her documentation. Also, check both refrigerant systems for pressure. So you're not gonna go by the panel, you got power off. That means you gotta put your refrigerant manifold gauges on there for the proper refrigerant. Now, the refrigerant going through this machine is 410. The type of oil that's associated with this machine is an ester oil. You wanna make sure you use the appropriate gauges, because if you got R22 gauges, R12 gauges, that has mineral oil. Mineral oil and pea oil does not mix, so you can have some residual oil that can actually lead to catastrophic effects into the system. It becomes very viscous, it becomes sandy. Compressor rotating parts don't like that. Okay? Open each compressor service valve. You want to make sure that they're open, because again, the discharge line, you don't open that up. Again, this thing could become a bomb, couldn't it? Over pressurized vessel, right? So, but we have some devices in there that will basically prevent that, but we don't want anything to blow up, okay? Open pressure transducer valves, making sure that they're open correctly so they can read the actual pressure. Also, after opening these valves, before they do that, they should actually take the packing stem, okay? There's a packing hardware, okay? Packing nut. You want to unloosen that, take an adjustable wrench, and then use your refrigerant wrench to actually open up. Once you get it opened up all the way, some of our transducer angle valves, we go one turn in, and then we tighten the packing gland up, take the stress off the stem. If you were to actually open up your valves and all that stuff without loosening the packing gland, you will start having packing leaks, okay? Refrigerant leaks that are coming out. And again, you'll leak out your refrigerant, and they're a pain in the tuchus. You can try to repack them, but good luck. You're gonna have to cut out that valve and put a new valve in. Okay? Stop. It's done. Okay? Check the compressor oil level before startup, because if you don't have any oil in there, if you start it up, the rotating parts need lubrication. If it has insufficient lubrication, you can actually tear up a compressor inside internally from the parts, okay? It can lock up too. Check all fans for free rotation. That means they're going to be spinning the blades up there. They're going to make sure that the clearance between the shroud and the blade is not being compromised. Make sure it's not touching or interfering with the shroud. Because again, these are PVC plastic blades. They'll start to basically what? Lose their shape possibly. The length will also shorten because it's rubbing. Okay? That's going to cause the fan blades to be out of balance. The fan blades are out of balance. You're going to lose your bearings on the motors as well. Burn up motors. Verify all electrical supply connection wires. Check panels for foreign matter. We talked about the foreign matter here. Now, grounding. That needs to be verified as well, making sure that's the proper size, making sure it's on the proper earth ground. Check all electrical connections and terminals. Make sure they're torqued down tight. Verify site voltage. So again, if it's a 460 volt, hopefully that technician, when they power it up and use this phase meter, you guys ever see one of these? What's this right here? No, it's not a jump starter. Jump start your car, gentlemen. This here is a phase meter. Okay, so scroll compressors. These are what are on these machines. They're seeing a lot of scroll compressors, even screw machines. Okay, you're gonna check when you bring the power in. When you power this up, red, white, and blue. Phase A, phase B, phase C. So when you look at the teeth and we open it up, boy, brown, orange, yellow is 460 volt color code for the wiring for phases. Okay, brown, orange, red, white, and blue. Boom, boom. You apply the power, you push this button right here, clockwise rotation. You got the right rotation. If it's going the opposite, you're going to change two leads. You're going to lock out, tag out, go straight to where it's coming in for utility. Make sure, check with the meter. Just take B phase, bring it to A. A phase, bring it to B. Go back, power it up, check it again. You got the right rotation, you're good to go. The fact is, scroll compressors run backwards for any short time duration or a long time duration can do massive destruction. If you run them too long backwards, they'll lock up. They're done. Anytime you run them backwards, you're gonna do a little bit of apparent damage. You might lessen the life of the compressor, so go ahead and pass that around, okay? So again, just take a look there. So that's a phase meter there. So a lot of electricians are using these days because they need to incorporate that because making sure the rotation is correct, okay? Verify liquid flow corresponds with the design flow. So that design flow, we looked at it, right? So with this being converted at 6.9 delta, the actual feet ahead, that's about almost 3-pound pressure drop. So what can happen is, you know, we'll probably say, okay, we're gonna start the pump, okay? We'll start the pump, basically make sure we got the right pressure drop. Well, if it's not the right pressure drop and we have a test and balance person involved, or let's say on your guys' job, there was a test and balance, we'd have to go back to him and say, guess what, we don't have the right flow. You need to come back and get this corrected. Okay? We don't have to do it. Okay? Or Johnson Controls is not responsible for that. They just need to validate it. Verify flow switch is properly connected. Ensure temperature sensors are coated with the proper compound. Okay? Ensure that the chiller off-on unit switch is in the off position as well. So there's a rocker switch on the front of the human interface. It's on or off. Off is, if you use that button, the off switch is basically there for for emergency shutdown. I'll show you guys how to do a control shutdown. Breaker current frame size equals 400 amps. For this example, value of 0.4 is the default and must be added to other coefficients. Amp setting equals 0.4 plus 0.04 plus 0.32 multiplied by 400 would equal 304 amps. Or 0.76 multiplied by 400 would give me 304 amps. Now, when you're looking here, underneath here on this disconnect, there's some switches here. All these switches need to be actually configured correctly for a short circuit. Now, we see unit switch T1, that must be up for 3 seconds because again, a short circuit, we want it to catch it quite fast and shut down the machine for proper isolation, okay? Normally set to S, okay? Now if we take a look here, you got all up here, so these all have to be all up and all down here when this is all set up for breaker setting for instantaneous short circuit. Now the condenser fan clearances, again, we're making sure that these are rotated, making sure they're not interfering because remember, this has been transported from Monterrey, Mexico. Depending where this is going to be landing in a part of the North America, this thing's sitting on a flatbed. Some of the road conditions are pretty lousy, right? So these cradle mounts can come loose and the fan motor can slip. So what will happen is the startup mechanic will have to pull the cage off and actually recenter that and check to make sure it's not interfering with the shroud. Also, all refrigerant valves must be open, so you can see a lot of the valves here. We'll walk out to the machine. I'll show you where some of the valves are that are all open now, but before they even apply power with power off, they're going to validate all the valves are open correctly. Okay? Also, tighten all packing nuts. Leak check the unit possibly if you don't have refrigerant. Now this is a thermal dispersion sensor right here. This dimple here, what you're going to see on the machine here, they got a thermal dispersion. This is an electronic. This is not a mechanical flow switch. This is monitoring the flow to the evaporator. This dimple needs to be pointing into the stream of the water flow. This here has 2 heaters, one up here, one down here. As the water goes by this tip right here, this is being cooled off, so they're seeing a delta T, okay? So the contact's closed saying you got flow. If we start to actually lose the flow slows down. What will happen is that voltage will drop down to less than 1 volt DC. It will open the switch. More than 4 volts, it's closed. So that there is an electronic switch here. So with the flow sensor, so we can get a better idea of it, thermal flow sensor page 41 in the ICOM 6. So let's actually go here to the ICOM 6 and we'll go to page 41. Let me scoot this over here. Yeah, you can see here's the operating principle that I just explained. But if you take a look at the pin layout here, so when a mechanic, maybe they have to take a look at the pin connection because that might come loose. They might not have proper flow. It's not reading it because it's not connected correctly. But these pin connections, 1, 2, 3, 4, and 5, they're allocated. One's for voltage and one's for the contact. Pins 1 and 3 are used to connect with 24 volts from the transformer T1, terminal 40 and 41. See the red dot on the framing, figure 14 on page 60. Pins 2 and 4 are used the output status of the thermal dispersion flow switch. These 2 pins need to be connected to terminals 13 and 14 of the terminal block XTBC1. So when we take a look here, this here is the pin allocation. So this is what's happening here. When we take a look here, we've got 24 volts right here. Okay, that's going to power up this flow sensor. As long as we got power here, it's going to have power at all times. When the pump starts and we send flow, these are the contact points. This is normally open. So basically, when that flow starts, this signal here is going to get greater than 4 volts DC. That will close that switch. When we start to slow down the water flow, or let's say the pump stops, this voltage is going to get less than 1 volt DC. It's going to open. Okay? That's for the contact closure there. Okay? So that's the thermal dispersion right there. Okay? Now I'm going to go back into the PowerPoint. Okay? Now if we take a look here, when we take a look at the thermal flow set point, okay? Take a look here. 6.6 feet per second for round tube, that's the minimum. 1.9 feet per second for brazed plate heat exchanger. Okay? Manufacturer states, not stats, the dimple should face in the flow, but that it would work in most applications regardless of where the dimple is facing, but that it would cause a problem when there are rapid temperature changes or load fluctuations. Okay, so that's critical. Now not only that, when you're running the actual flow too slow to the evaporator, basically low velocities through the heat exchanger will increase the film factor, meaning fouling factor. Again, you can actually have your suspended solids drop out. The relationship between the medium giving up the heat and the heat exchanger surface. This relates to the velocity is too slow. The film between the medium and the heat exchanger becomes greater and becomes an insulator. Okay? You're just talking about fouling, meaning that the evaporator is getting plugged up. Now, if we take a look at the this paddle switch here, this is a NEMA 4 waterproof enclosure. Okay? One thing is too, if you guys are using flow switches here like this that are going back to the panels, what's recommended is taking a high temperature fire rated RTV, the red stuff, filling this up here and going back to the panel and basically making sure that's filled up, because if these paddle switches start leaking and you got this NEMA 4 enclosure, that water can go all the way through this conduit back into the panel, the control panel, and basically start squirting water. And we've seen that before, okay? Not only on trains, carriers, all different manufacturers. So it's just good habit. We talked about these here for the mechanical here, switches here, DP, differential pressure switch, and a paddle. These are both mechanical. Right? Now, when we start talking about flow or pressure differential, on that sales order we saw what? A pressure drop design of what? 6.9, which comes out to 3 pounds. Now, this here is basically a flow chart, okay? One of the things is when you're looking at your evaporator, you want to look at the model number of your machine. We broke down the model number, but when you start breaking down the model number here, like a YAA 058HE or what have you, start following this. Basically, what you're going to see here, let's use B for instance. This is the minimum, okay? This is a little bit over 1 pound gauge pressure drop, okay? Probably about 1.8, 1.9. This is the minimum to the maximum. If you don't know the design, always shoot for the middle. Okay, so if I'm in the middle, I'm using this. I'm looking around, let's say 9 psi. Okay, that'll keep the machine running, but you're not going too fast, because if you exceed B at the highest level, if you have velocities that are too slow or too high, you can destroy the heat exchanger, whether it be the round tube and the tube type of heat exchanger or the flat plate. Okay, so this has to be followed depending on the model number. You'll take a look here, but it's best to possibly, hopefully, a good startup mechanic's going to use a mark slot and put the design pressure drop, okay, and the GPM in there. Okay, they'll fill it out. As a matter of fact, I'm going to put it in the panel at another day. All right, so I'm going back to the actual PowerPoint. So we looked at that. So that's the flow right there. Now take a look at these compressors here. These are belly band heaters going across the actual bottom of the crankcase of the compressor. You can see here, this basically almost looked like basically a pipe clamp almost, right? A hose clamp. But this fits here. Very critical, the height where this sits. You don't want to set it too low. Down at the bottom, you want to set it at the proper height. But the different types of compressor, different sizes require different size heaters. A bigger compressor is going to require what? A larger heater, because it's got more capacity of oil in there, doesn't it? Okay? So we got more oil in there, we need to use a bigger heater to pump any refrigerant. So because again, if we got refrigerant in the oil, liquid, you can hydraulic the compressor, slug it, and damage it, scramble it. Okay? So we don't want that. Now, not only that, if power is off for more than 2 hours, the crankcase heaters must be energized for 18 to 24 hours prior to restarting the compressor. This will ensure that the liquid slugging and oil dilution does not damage the compressor on start. Okay? If we take a look at the oil levels, you're going to see basically some equalizing lines. You're going to see some sight glasses here. In that sight glass while the machine's running, it should be between 1/4 and half in the sight glass. Okay? Also, anytime the system is open, the filter dryers need to be replaced because, again, two different types of, it's an estrol. It's very hygroscopic to moisture. Okay? So if you see a change in color of your oil, it should be pretty clear. If you start seeing it looks brown and all that, send it out for an oil sample. You want to get it checked for everything. Metal content, copper, every steel, stainless, everything. Also, total acid number and also water. How many parts per million? Most of our machines here on the closed loop, on the refrigerant side, less than 100 ppm is acceptable. That's very, very minute. Okay? If you get something that's too high, that's not good. Now, power on, verify pressure transducers. So basically here, they'll keep their gauges on, they'll look at the feedback from the transducer screen, making sure they're mapped out correctly. Verify temperature sensors, so they're going to verify the temperature sensor, making sure that they're tracking the correct leaving water temperature, outside ambient and all that stuff, because the outside ambient temperature sensor is critical. Because what happens is there's heaters on the flat plate heat exchanger when the machine's setting idle. The temperature, outside ambient temperature drops to a certain temperature, it's going to energize the heaters on the actual evaporator and also on the hydro kit that's on there. You're going to look at this yellow wiring there. Okay, that's the heat tape in order to prevent any of it from freezing up. But when the machine starts up and the flow's pumping and all that stuff, it could be less than 40 degrees. But guess what? The heater's de-energized because we got flow. What we're trying to do is prevent the machine from icing up when it's setting static because you have no flow. Okay? Now also through your transducers, all these connections, a good best practice, it takes a 3M tape here, electrical tape, and tape these up because again, this is outside with the elements here. You got heat, you got the temperature, what? Expansion and contraction, right? What about corrosion and all that stuff on the shield from moisture and the pin connections and everything? Plus you can also use some dielectric grease here for these connections so they don't get corroded, okay? Test the condenser fan operation. So again, we can test these here manually, but they're showing you here this doesn't have this added feature. We can actually use the service test mode and test a lot of the outputs except for the compressors. Okay? That's to test the condenser fans. Okay? Now when we start running the refrigerant, the machine here, when the startup mechanic's running these machines here, they want to check for a clear sight glass. So that means that when they started up the liquid line sight glass, they'll get all compressors running for that circuit, make sure the subcooling set correctly, as well as the actual suction superating. Okay? So they'll make sure they get it 100%, check in subcooling as well. Okay? Also check for the sight glass, no bubbles, listen for any abnormal noises. Because again, if the compressor sounds pretty junky, sounds like it's swallowing marbles, not good, okay? So there could be some problems going on. Some ballpark numbers to look at. If you take a look at the discharge pressure with your manifold, you can add 30 discharge pressure at 30 degrees above outdoor ambient. So take the ambient temperature, let's say it's 70 degrees, add 30 to it, go to appropriate PT chart, pressure temperature chart for that refrigerant. We can look at the pressure and basically we'll be able to see that this machine is running correctly and possibly have the right refrigerant charge as well possible. Now if we take a look at the actual suction saturation tip, with 10 degrees Fahrenheit of leaving water temp, okay? Amp meter verify fans and compressor run load outs within 10 degrees Fahrenheit of leaving water temperature, okay? So that's approach. So we take that temperature there, we take the leaving water temp, it should be about a delta T of 10 degrees, okay? At full load. Now, subcooling right here. So when they're taking the subcooling right here, they're going to be actually putting a gauge right here on this circuit here, circuit number 1 or number 2, which whenever they're starting up. As a startup mechanic, if they know that machine, if he or she knows that machine, they can go in there and isolate the circuits, number 1 and 2, and start them up independently. That's probably the best methodical approach to take on when you're starting multiple circuits. Due to the fact is, you'll probably be able to put a load on 3 compressors. You don't need to run all 5 or 6 or whatever, how many's on there at the same time. Isolate each circuit. even when you're replacing the compressors and all that, checking all this, okay? It's easier, it's gonna be faster, you're gonna be more precise with your dialing in the subcooling and superheat, okay? Now, they say 15 degrees, but 18 degrees is the design here. We take a look at the superheat here, suction superheat. So they're looking at the actual, from the compressor suction line and also from the evaporator pressure. So we'll take a look here, it should be about 12 degrees. And again, 10 degrees for YLA, 10.8 for YLPA. Single compressor running on each circuit, okay? Within the system running stable for 15 minutes. Verify correct superheat. So if we have 2 less of superheat, so I got 2 degrees superheat, I got liquid coming back to the compressor. It's not conducive. So if you got basically, let's say 12 degrees or whatever the design is, you got vapor, because compressors are designed to pump vapor refrigerant, not liquid, okay? Liquid is not conducive. Now, all right, let's go outside here. You guys want to bring your books, that's fine too, okay? Man, time flies. Doesn't seem like we've been in here that long, huh? Holy cow. Okay, we're gonna take a shortcut. We're gonna go actually to the lab, okay? I'll show you the shortcut here. Does anybody have to use the restroom before we go outside? Have a good night.